Weld inspection. Learners will be able to inspect a weld from a visual appearance, visually looking at the weld and determine whether or not the weld is serviceable. Inspection of welds. A properly created weld joint is going to be stronger than the original material being joined. What does that mean? That means if something breaks, it's not going to break in the center of the weld, it's going to break where the weld actually attaches to the two metals being joined together. A visual inspection of the weld is not always a good indication of the overall quality. It can lead and it can give us some indications, but it's going to provide us some clues, but it's not necessarily the total end answer. Characteristics of a good weld, some visual characteristics, is does the weld have a uniform width? Is it even all the way down? Are the ripples along the weld even? I've heard it explained that if you take a roll of quarters and lay it out on a table and you get that nice even, that's what a good weld should look like. Or maybe a roll of dimes actually looking down, how we've got the little bitty nice, everything's nice and even and nice and straight. The ripples of the weld, do they feather off into the metal even? Do they bulge up or do they undercut? Going to tell us if it's a cold weld or a hot weld. The surrounding material. If you get much more than 1/4 of an inch from the side of the weld, if you start getting burn marks out there, tells you maybe the weld was too hot. Maybe there was didn't have enough of the proper gases flowing and stuff like that to keep oxides from getting too far out from the weld. Characteristics of a good weld. Did they achieve good penetration? Did it penetrate fully through the metal like it was supposed to? If it was a butt weld, you should have 100% penetration. Is the weld free of gas pockets? Is it smooth? Can you start seeing pockets down inside that weld? What about the straightness of the weld? If you look at a weld and it's kind of zigzagging back and forth, that doesn't mean it's a bad weld, but it certainly would lead me to believe that it could have been better. It may still have the strength, but it's going to make me want to go ahead and inspect it just a little bit closer. The depth of the fusion of the weld. The measure percentage of the thickness of the metal. How wide the weld is versus how tall it is versus how deep it goes. This is going to be affected by the thickness of the material being fused together. When you're actually doing arc welding or welding TIG or MIG, you're actually fusing two metals and making them one. Different than when you're brazing or when you're soldering, you're just adding a glue. This is actually a fusion process where we're taking two metals and making them one. The thickness of the material is going to impact how much heat you're going to use. The size of the filler rod is also impacted by how hot it is and how thick the material is. And then how we actually add the rod, the rate at which we add the rod. All of this plays into the type of material, the thickness of material, the heat. This all plays in together. Again, I'm not going to make you a welder by watching this video, but I'm going to try to help you to understand what you're inspecting for when you're looking at a weld. What are some of the defects that we're actually looking for? Different types of weld are going to have different penetrations. If you have a butt weld or two pieces that are actually coming together, you should have 100% penetration. In other words, you should see, if you flip it over, you should see the weld actually coming through the bottom portion of the piece of material. On a fillet weld, where we're actually welding in the side here, you're going to get 25 to 50% penetration. You might be able to see it on both ends, but you're not going to see it in the center. You want to make sure that it's not undercut, especially the part that's up on the top. Want to make sure we don't have an undercut going. Some characteristics of a poor weld. If you've gone too fast, maybe the edges of the ripples are going to be a little bit sharp. It's going to contain some pockets within the weld, some gas pockets, some porosity, some slag. The flux that you use on a welding rod, maybe that's going to get back up in there. Okay, so there's going to be some defects. When you actually weld too fast, you're not burning off all the contaminants. You're going to get some more defects and stuff in the weld. Insufficient heat. Maybe I didn't have my welder, my amperage cranked up high enough. We're not going to get good penetration. The weld isn't going to flow into the material very good. The edges are going to be rough. They're going to be irregular. And the edges, they're just not feathered nice into the material. A nice weld should feather off nice into the material, nice and easy. Excessive heat. Maybe you're going to get boiling, you're going to get craters, you're going to get pockets, you're going to get cracks, you're going to sometimes get a pointed. Instead of a nice round weld, you're going to get a pointed weld. So there's different defects that you can look at. If you inspect a weld, you can tell whether the individual was going too fast, he didn't have enough heat, maybe he had too much heat, or she, I say he, could be a she. The welder had some things going on that caused us to get a poor weld. So welds can be inspected by quality. You can do a visual inspection on the weld, not necessarily see what's going on underneath, but sometimes just looking at the surface is enough of an indicator to reject the weld. Does it mean the weld is bad? Not necessarily, but it's certainly going to make you inspect it a little bit more. Again, we talked earlier about non-destructive tests. If there's question, x-ray the weld. That'll tell you what's going on underneath the surface. Good welds are going to provide adequate penetration, uniform ripples, feathered edges, no signs of burning, especially once you get out about a ½ inch or so beyond the weld itself. It's going to be stronger than the original material itself. Again, that means that if something was to break, it wouldn't be the weld, but it would be the material, maybe to the left or to the right of where the weld is at. Poor welds, not always detected visually. Sometimes you're going to have to get that x-ray in, and you're going to actually have to look underneath and look for the inclusions and look for the slag and stuff that's in there. Some of the stuff you're going to notice visually on a weld, though, maybe it's not going to flow into the surface really good, nice and feathered out. Maybe it's going to be undercut. Maybe your ripples are going to be a little bit pointed. These are going to be some things that are going to indicate that we had a bad weld. The weld was too hot, the weld was too cold, the weld was too fast. Some different indications that we're going to determine that there was a bad weld.